Today we're going to start chapter 5. So we're actually skipping chapter 4. We may go back to that a little bit later. But we're starting chapter 5, and we're going to talk about systems. And what is a system? And we're going to try to solve these by graphing. What I would recommend is that you go back to the warm-up and do the warm-up where you're graphing these two equations on here and see if they intersect and figure out if they do intersect, where do they intersect at. That will be answered later in the lesson. So you do that on your own. So what are we going to do today? So what is a system? Talk about that. And then what's the purpose of actually graphing it? So we're actually going to learn multiple ways of solving systems. Today is just going to be with graphing. And we'll use Desmos a little bit. But most of it we'll do by hand when we graph it. So a review of what a system is. I'm not sure if you covered this last year or not. Maybe it'll be familiar to you whenever we do it. I'll show you what it means. So what is a system? It's just multiple mathematical equations in one given situation. Multiple equations in one situation. Let me give you an example. Usually they use this curly bracket that we're used to seeing when we did piecewise functions. So I'll give you an example. Y equals 3x plus 10. So that'd be one equation. And then I will throw another one in there. 2x plus y equals negative 4. Right? So these two equations in this specific situation is a system. You can have more than two, but you have to have at least two, and that makes a system. You can have 3, 4, 5, whatever. It doesn't matter. So then the terminology down below, you might not know exactly what this means, but anytime you see these words, to find the solution to a system, might sound kind of confusing. A system, remember, is just multiple equations. To find a solution to a system, so if you have multiple equations, so with equalities, which means when you have equal signs in here, it's the intersection of the different graphs. So when you're finding the solution to a system, that's where they intersect each other. Specifically, we're going to be talking about two equations, although you could have more. But we're only going to do two. So we're going to be graphing two equations and seeing where they intersect. That will be the solution. So like I said, you should have gone back and done the warm-up question. And the answer is, what is the solution to the system in the warm-up? That means, where do they intersect? And there should have been an intersection point. If you did the warm-up, I would, again, suggest you do it. And that should have been 2, 1. That's actually where they intersect. And then part A, to follow up on this, how many solutions can a linear system have? So how many times can two lines intersect? That's the question. So hopefully you can figure that out. If you only have two lines, you only have a couple possibilities. The most you can intersect would technically be 1. But we're not going to answer this. We're going to move on and talk about what kind of possibilities can you have. So the first possibility is that they actually don't intersect, right? It's called no solution. That means they don't intersect at all. The graphs will never intersect. And we've already talked about this, so here's an example. You have two lines that you draw. You say, hey, they're not going to ever intersect. They're called parallel. The lines over here are called parallel. They never intersect. But these go hand in hand. If you ever get a graph like this, you would call this no solution. There's no solution there. No answer of where they intersect. The next possibility would be like what you did in the warm-up. If you graph those two, you get one solution. That means they intersect at one place when the graphs intersect once. That's the second possibility. So if you look at this graph down here, it shows you what two are being graphed on the coordinate plane. We have y equals negative x plus 2, y equals x plus 4. And the question says, what is the solution of the graphs to the right? So the solution to the system of the two equations here would be where they intersect. So we just have to figure out what is that point. And that would be negative 1, 3. There it is. That's the solution to the system. And there is one more possibility. So we had no intersection point at all, parallel, right? No solution. We had one solution. There's one more. That would be infinitely many solutions. So when does this happen? This would be only if the graphs overlap each other. In other words, they're the exact same graph. They may not look like the same equation, but they're the same graph. So I'll give you an example. This specific line here, I'm going to show you two different equations you could have to show that this is the same line. The first one is this one, which we'll talk about how that works in a little bit. But the second way that this could be written is we could actually solve this for y. So if we go to example 4, one equation of the graph is given below. So here's one. Find another form it could be written as. What I'm going to do is just basically solve for y and show you that it's going to look different, but it will be the same equation whenever it's graphed here. So this would be an example of infinite solutions. I'll show you. Let's solve this for y. What do? We can bring the 2x over by subtracting it. And so that goes away. We get 3y equals negative 2x plus 3. And then we could divide by 3 to both sides. That goes away. We get y equals, 3 has to go into both of these, so I'll keep this side here as a fraction. Negative 2 over 3x plus 3 divided by 3 is 1. So it is possible that you could have this original here and this new one as a system. So the question could say, what if we had, 2x plus 3y equals 3, and the other equation was y equals negative 2/3, x plus 1. You may not know it by looking at it, but they have the exact same equation. How? Let's talk about this one first. This would mean, how you graph this, would mean you start at 1. Here's 1. Pull a dot there. There's 1. It even says it's 0, 1. And then you would go down 2 blocks over 3. So 1, 2, 1, 2, 3. Intersect right there. 1, 2, 1, 2, 3. So you can keep doing that, and you hit the line every time. So that is the line for this equation. Now, if we go back to the original here, this should also be the line for that equation. If you look at, say, the x and y intercept, remember the shortcuts, that would be like c over a, 3 over 2. That's 1.5 right here. Here's 1.5. And the other one would be c over b, 3 divided by 3. So the y-intercept is 1. There's your 1. You could also do the shortcut for the slope. Remember, it's negative a over b, which would be negative 2 over 3. It's the same slope as the one down here, down 2 over 3. So it all matches up. These are the same two equations for the same graph. So the answer here would be infinite solutions. They're actually the same line overlapping each other. Those are the only three options you can have. You can have parallel, which means it's no solution. They never touch, never intersect. You have one solution, or you could have them overlap, which is infinite solutions, because they all have points in common. It'd be like one line on top of itself. Now that we know this, we're going to try some. For example 5, what is the solution to the graph? And also, how many are there going to be? Well, we can clearly see that they intersect each other. So we have one solution, and then what is that solution? Let's just look on here and see what point that is. They even tell us what the equations are, although we don't need to know that. We're just looking at the graph. That would be 2, 3, 4. This would be 5, looks like. 5, comma, whatever that point is here, 20. So the solution is 5, 20. Nothing else to do. X is 5, and then y is 20. Alrighty. I think we only have like one or maybe 2 or 3 left. Then you can finish the rest. It's going to be pretty short. Our example 6, solve the following system. So what basically that means, we're going to graph them and see where they intersect. Or if they don't at all, we would say it's no solution. If they overlap, same line, we would say infinite solutions. So let's see if we get a solution here. So y equals 1/2 x plus 5. We'll start at 5. Put a dot there. And then our slope, remember because we start at the y-intercept, the slope means we go up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Oops. Or you can go down 1 over 2. Down 1 over 2. Down 1 over 2. It's probably best to just put a couple points and then use a ruler so you can actually see where they might intersect if they do. And I can't draw it straight, so I'm just going to try my best. There we go. So that takes care of the first one. I'm going to change colors and do the second one in blue. So y equals 2x minus 1. That means we start at -1 on the y-axis. There's your dot. And now this slope is 2 over 1. So that's up 2 blocks over 1. Put a dot. Up 2 blocks over 1. Up 2 over 1. And it looks like it might intersect in this next point here. I don't know why my cursor's not showing up. Up 2 blocks over 1 right here. Looks like we already found the solution. Once we have that, we can just draw our line as best as possible. And we just need to identify exactly where they intersect. So where is that point? 1, 2, 3. Looks like it's 4. If we go up from here. And 7. So the answer is there's one solution, and it's 4, 7. I'll even write that. One solution. And what is it? 4, 7. Simple as that. So we solved the system of equations by graphing them and seeing where they intersected. So the next one we're going to do is not as easy to see the intersection point because not all the time do they intersect perfectly at these nice points like 4, 7. There could be decimals. So if that happens, we have to do it in the calculator. In this case, I'm going to show you how to do it in Desmos, and later in class, we'll do it in the calculator. I'll show you how to do that there. So solve the following system using a calculator. So we're actually going to graph these, and then I'll just make a sketch on here as best as I can. But if you remember, this equation here is going to be a little different. We're used to only doing linear equations, which means they're going to be straight lines. This one will be a little different. This is kind of going outside the scope of what we just talked about. If you remember this x squared, that means we're going to have like that sad face kind of graph like this because it's negative, a negative 3x squared. And then this will be a straight line down here, and we'll see kind of where it goes through. So I'm going to go to Desmos, and we're going to type it in. So desmos.com/calculator. The first one was y equals -3x, and then we can hold shift, hit the caret button, which is number 6, 2. So there's that graph. And then if we hit enter here in the line, in the box there, it gives us another box. The other one is going to be x minus y equals 1 on here. So we actually have to put it into y equals. So let's solve this equation for y. So how do we get the y by itself? Not too bad. We just have to subtract the x on both sides. So it becomes -y equals -x plus 1. They have to be separate. And then we'll just see we have a -y left over when we bring that down. So it's like a -1. We have to divide by -1. So that becomes y equals -x over -1 becomes a positive. You can put 1x if you want. 1 divided by -1 is -1. So 1x minus 1 will be the equation. I actually don't know if Desmos does this equation. I don't know. I can check then and see. But I'm going to put it in y equals x minus y. Whoops. That's not it. It was 1x minus 1. There it is. And so Desmos is really nice because it actually just tells you the intersection points. If you see like the little highlights here, it tells you where it crosses the y-axis here, and it tells you where they intersect each other. So if you zoom in here a little bit, right here, you can highlight them. There's your point of intersection. It actually intersects 2 times. So we have this sad face shape. Intersects here. So the first intersection point would be 0.434, comma, -0.56. And then the other one would be -0.768 and -1.76. Pretty ugly numbers, but it's possible. It's just easier to do in the calculator than trying to figure this out yourself. Us graphing it, we won't be able to figure out these exact numbers. So it's a little easier to do this on the website. So I'm just going to put a sketch on the paper as best I can, and then we'll just mark it, the intersection points. So it's going to be something like this. And then the line goes through. It's not going to be great, but we're just going to try it. Something like this. Whoops. Oh, no. Don't want to do that. Let's go back to this here. It's not the best. Okay, you make sure it's a straight line, and then we'll mark the intersection point. So let me use black here. So here and here would be the two intersection points. And what would we say that was? Just go back and look at it. So 0.43, negative 0.56. I'm rounding it. So this would be 0.43, negative 0.56. And then the other point would be negative 0.76 and negative 1.76. So this one over here is negative 0.76, comma, negative 1.76. Really nasty decimals, I understand, but this is the first time we actually will see two intersection points, and that is only because we're not graphing linear equations. Whenever you do a parabola, which is what this is called, the sad face here, you can have actually more than one equation. All the ones that we did before, the infinite solutions, the one solution, and no solution, this is all based on drawing lines, straight lines, not having the curves. So those are the only options when you draw straight lines. Obviously, it's a little different here. I think I'm going to set up the next question and then for the huddle. So that way you guys can do that one, and then I'll be done. So let's read through that one. Suppose Ben and Lisa are putting money away into their savings accounts. Ben deposits $30 initially into his account, and then every day he withdraws $5 for an after-school snack. Lisa deposits $45 initially into her account and then withdraws $10 every day to buy a snack for herself and her best friend. We're going to solve this problem by creating two equations and then use the table to make the graphs. Graphs should go by fives on the y-axis, which I feel like we could probably just do it by hand. We actually don't need a table for the most part. So let's do two different equations. We have Ben. We got an equation for him, and we also have Lisa. So Ben's equation, he deposits $30 originally, but he's taking out $5 every single week. So the equation would be, so this would be $5 per week, or every single day, right? $5 per day. That's kind of like your slope. We have an initial part of $30, initial starting amount $30, and then we're going to go down 5. So it'd be like y equals 30 minus 5x. Or you could say negative 5x plus 30. That's Ben's equation. He starts with $30 and then is dropping $5 every day. Lisa is starting with a little bit more. She starts with 45. But then hers is going down $10 every day, so minus 10x. So then when you graph this, just make sure that you can get up to 30 and 45. And then you're going to be going down 5 over 1, down 10 over 1, depending on your scale. You graph it and see where they intersect. That's your answer for the solution. And then figure out what that means in the context of the problem. So when you're finding where they intersect, what does that mean as far as Ben and Lisa's money? Well, you'll figure that out whenever you get the point. But that is everything for this lesson for graphing solutions. And we'll see you next time.